So we're presenting on the open source spectrometer project, or at least that's what we were calling it at the beginning of the summer. We've done a bunch of other stuff as well, and we'll talk about that. Tim is our third team member. He slept late, I guess, and tried to run halfway through his presentation.
He'll be hiding directly behind me. You just can't see him. He's right back here somewhere, but he's hiding from already.
So we've done most of the design and the engineering work for the optics and the electronics for low-cost spectrometer, and we had most of the parts for the prototype. And then we spent the second half of the summer working on other stuff. This is still in progress. We will finish it at some point. However, some of the parts needed for it, like that miniature Linux computer, ended up being basically another sub-project that we decided to dedicate a lot of time to and sort of put the spectrometer on hold. So that Linux computer is still not quite ready. PCB design's in progress, and we've done some prototyping stuff. And as you've heard before, it's low cost, relatively powerful. Basically everything you'd want in an embeddable Raspberry Pi-esque thing, but smaller and able to be put inside some other circuit. So another big thing, not really related to this project, but my company, Lib3, is finally getting headquarters. We're setting up an office downtown and a manufacturing floor where we're going to be establishing some PCB assembly services. So we're currently retrofitting and renovating an industrial building downtown. And yeah, so we'll be doing that during the semester a lot. Should be fun. We're also going to be at Maker Faire again this fall, doing a booth that has open hardware designs that we've done, so a bunch of stuff you've seen here before. Hopefully we'll have a little Linux board ready for that. We'll also have the pilot and some other open source hardware things on display. And we'll also have a miniature PCB assembly line set up there where we'll be manufacturing on demand little circuit boards for people that come to our booth. So that's about all we have about the spectrometer. There's a bunch of other stuff that's been going on, but to keep everything short, I'm not going to talk too much. So this is Nick.
Okay, and I worked on the Embed GUI project, which is related to the spectrometer. It's also related to VitalVito. So basically, an overview of the project is that I was working to create basically graphical prototyping for GUI. So it's fast prototyping for people probably generally working with other projects. So if you're doing something that it does something but you need a GUI, this is just a drop-in, really easy to do. Basically, the hardware that I use, we've got the microcontroller, the screen, the Bluetooth, wireless. The development cost for this is about $130, so you can get that. But the board is actually an open source hardware board, and the processor on it costs maybe $10. So, and you can get the screens, you can get maybe another Chinese branded screen for maybe $5, $10. So, for development costs, it's going to cost this much. But if you want to use an industry product, a commercial product, you can make your own PCBs and you can make a touchscreen interface for $20, which is pretty good.
I don't want to interrupt, but it's worth noting that the CPU on the development board for this project is the same CPU that's going to be on the Linux board that Jarrell and I were talking about.
Yeah, our design is based off of the open source design that this board uses.
Okay, and yeah, so the objective is basically, I was able to complete everything I set out to do. We got Debian's fully running on it. You can run XFCE on it, so if you want to run a graphical desktop, you can do everything you can normally do on Linux. A lot of people use them for CNC machines or other things, so it's fairly powerful microcontroller. We got cross-compiling set up, which means these run ARM architecture, so it's important to be able to develop this on your own computer and be able to just compile in ARM and then send it over rather than having to compile on the device, which is particularly important for doing stuff with Qt. The big step, the most important thing that I was able to do is get Qt correctly running with TSLib. When I talked about Qt a little bit before, it's an open source, cross-platform graphical library, and it can run on the embedded device without graphical limits. And then TSLib is a generic touchscreen library. This was a little bit difficult to get compiling because Qt takes maybe 4 hours, 3 or 4 hours to compile, even on the ThinkPads running all the cores. And it takes like 50 arguments for your specific device. So it'll go about 2 hours in and then crash because one of the arguments. So actually figuring out what it takes to get it to compile is pretty big. And then getting it to cooperate with TS-Lib because we had it working and touchscreen wasn't working, but that's all functional. And then I created a couple prototypes, which takes, at this point, maybe 1 or 2 days programming. It's really quick. So I've got a couple demos, short demonstrations.
We actually brought the hardware to have as an actual demo, but I forgot the power supply, so.
So I mean, the button's doing too much because normally it would be communicating something else. This is, it's got 5 channels from 0 to 4096. So you can send these values somewhere. And the IDE for developing these is actually a drag and drop IDE. So you need to do a little bit of the input handling after you just drag and drop it. I mean, it's really easy to make this stuff. And then the other company that I was working for, I think Open Spectrometer is looking to use this, and then VitalVio is it's an RPI grad program where they're making some biomedical lighting, which kills bacteria on surfaces, and they want to use this in hospitals. So this controller is something that in the future you may be seeing in hospitals as like a replacement for a light switch. And so this is the current prototype for that. Just got a couple settings. It's got a slider for dimming, a couple settings for various lighting levels, power levels, color selector, so you can change the color of the lighting. And then the way on-off works is it's black by default, and you just would touch the screen and it would turn your lights on, and the interface would go on. So. I'd like to thank Sean O'Sullivan, Morphy, Goldschmidt, and all the RCOS members for your guys' support, because I know this would be possible without that. Are there any questions?
What IDE do you use to put out the GUI for the method?
It's called Qt Creator.
Okay.
So
How responsive would you say that GUI is?
I think it's fairly responsive. Some of the stuff that's a little tricky is like some of the sliders and stuff are more designed for clicking, and so like it's not as like it's like some of the people are used to using Android applications or something where it's like big and they can grab it and it doesn't exactly work. But other than that, it's pretty instantaneously responsive, and you can get around that by designing bigger buttons or things like that. So
Additionally, I think there's some tuning you can do with touchscreen sensitivity to make it be more likely to get the click the first time. Right now, I know works great for Nick.
Yeah.
Works pretty good for me, but Colleen, the CEO at VitalVio, has had so much trouble operating it
it's got
for one reason or another. So I think the sensitivity may also need to be adjusted, but it is definitely responsive enough to be used in a real-time control.
And the other thing that makes it responsive is the fact that it's not running so much other stuff, and it's a powerful processor running this simple program, so that helps with it too.
I'm just curious, you're using a resistive touchscreen?
Yeah.
Yeah. And just a little UI recommendation on your little color picker. If you put the color in the inside and the selector on the outside, then you can have a bigger button with more spin.
Yeah, well, the reason that's kind of a hack. Literally wanted one of those gradients, but there's just a default slider button, and then that's just a picture of it behind it. But yeah, that would be a better way of doing it.
Right now, all the GUIs that have been created are basically mock-ups of what could be used in the future.
Okay.
Any sort of control thing like that is going to be developed with input from hospitals based on what they actually want for an interface. So, I mean, the interface might end up looking totally different, or might just be a single on-off button on a touchscreen. But it's really going to be driven by what the people will be operating.